and find length of arcs. So mainly 3 things to do, and then we should have some working time because I'll be giving you that cumulative test to start today.
Oh.
Alright, so first of all, what a sector of a circle is, I don't know what that definition is, but a sector of a circle is a region bounded by 2 radii of the circle and their intersected arcs. Okay, a sector is really named by its central angle. Maybe you have to write that. No, I guess it's not. We're on the wrong page. We're on section 11.3. 11.3 is what we're filling in here.
Bless you.
We skipped
Bless
it
you
on
too.
Friday, but now we're doing it. Okay. You name a sector by its central angle, and it's a like piece of pizza, it's a slice of pie, it's part of a circle. Okay? Now how will we find its area? How much pizza do you get to eat? Well, what's the area of the whole circle? How do you figure that?
Pi r squared.
Pi r squared. If it were half of the circle, like a semicircle, how would you do its area?
Pi r squared.
Pi r squared times a half, right? What if it were like a 90-degree section?
Pi r squared.
4.
Yep, so where are you getting the 1/2 and 1/4? What are you really basing that on?
90 divided by 360.
Correct, it's that central angle out of 360. So if that central angle is a 100-degree, which is maybe what's up there, it's not a nice fraction like 1/4 or 1/2, but it would be 100 out of 360. That would be the fraction of the circle that that sector is. So to do its area, you'll take pi r squared times the fraction 100 over 360, or whatever the degree measure is. Okay? And that's what this is talking about to come up with the formula. Area of a sector is pi r squared times the measure of the central angle, which is the same as the arc, over 360 degrees. Some of the fractions will reduce nicely, some will not. I think lots of times they're just saying keep it in terms of pi, so we'll read the directions. So let's do some practice calculations. Bring up the notes. Alright. Find the area of the sector and give your answer in terms of pi and rounded to the nearest hundredth. So they switched it up and made us do both. Okay, so start out with plugging into the equation. To keep it in terms of pi, just calculate everything except the times pi part. So do radius squared times your fraction. And let's try and reduce them as much as possible. Then once you write that down, then actually do times pi to finish it out. In the picture, it shows the radius is 1 meter, so 1 for the r, and the m is going to be 90, which is going to reduce nicely. So it doesn't come out, looks like 1/4 pi. Okay, so 1/4 pi, which they wrote decimal, 0.25 pi, and then when you multiply 1/4 times pi, it comes out to 0.79. All of a sudden now they're saying hundredths instead of tenths. Question on that calculation? Okay, next example. Okay, find the area of the sector. Answer in terms of pi and then round it to the nearest hundredth. Okay, so we should have 52.4 times pi square meters, or 164.62 square meters. Give me a thumbs up or down if you got it right. Anthony, you got it? Okay. All right. And how about a small sector? One comes out 1.74 times pi, which is 5.45.
That's what I got.
That formula understandable? All right, so I think we've got it. Skip that one. And where would you run across this? Something like a windshield wiper arm. Windshield wiper arm is 18 inches long to the nearest square inch. What's the area covered by the windshield wiper arm as it rotates through an angle of 122 degrees? That's saying, it's not saying the rubber blade, because that doesn't go way back to the center of the circle. So the whole wiper, that's it going back and forth.
Try to do it on the board.
Yes. Work ahead and see if he gets it right.
I can see you do it on the board.
And the answer would be nearest square inch. $345? Is your teacher right?
Quite possibly. I took the board.
Actually, I didn't get it switched into Keynote today, so it won't work up there. That's why I'm not writing up there either. 345, so what are you getting different? Let's go back to what you typed in. And you're using 0.33. Okay, that's probably a little bit of the error there. So times 122 over 360. That sounds goes up to 168 at 145. Okay, so you're going pi times pi. Now times. Okay. Now let's try and find the radius of the circle, in which the area of a 45-degree sector is 12.5. So I'm telling you the area of the sector, I'm telling you the degrees, and you're supposed to find the missing radius. So write down the formula to start with. Area of a sector. Area is that m over 360 times pi r squared. Fill in everything you know. (45 degrees) for the sector. A is 12.5 times pi. Okay, now how do you want to go about solving it? Various ways we could. What's something that comes to mind? Okay, we're going to try and find the radius because that's our only variable in the whole thing.
When the radius is be 12.5.
No. Because 12.5 is going to be this fraction times the radius squared. Let's divide by pi. Let's get the pi's out of there. And do you want to reduce the fraction? 45 over 360, I think, reduces nicely. How would you do?
It goes like
1/8. All right, so I'm to the point that I have 12.5 equals 1/8 r squared. So how do I get radius? Well, let's get rid of the 1/8. I like to multiply by its reciprocal. So multiply each side by 8. That means the radius squared is 100. So the radius is 10. About negative 10. When we solve those, you could have positive and negative. But it's a radius, so a negative doesn't really make sense in that problem. So 10 inches is my radius. Yes?
Could you just divide 45 by 360 and then divide it by 12.5?
Divide 12.5 by what you got in decimal, yes. So that would be, instead of 1/8, you're coming up with a decimal number. You're dividing by it and then square rooting. Yeah, could do it that way. Okay, let's go on to the next thing. The next thing today is what a segment of a circle is. Now look at this definition. A segment of a circle is a region bounded by an arc and its chord. So you make a circle, you draw a chord in there, and then what's between the chord and the circle, this part is a segment of a circle. Technically, the other part is also, but usually we look at the smaller region. We're going to try and find the area of that. How can you find the area of that? Could find the area of the whole circle, but then we have to take a lot of it away. If we would take the area of the sector, like this whole part, and then if we can find the area of the triangle, we can subtract that away, and what's left is the area of the segment of the circle. So that's what my notes there are. To get the area of a segment, find the area of the sector, and then subtract that orange area of a triangle. Now the picture that I've got on the board and up there both look like it's a like 1/4, like a right triangle in there. Those will be the easiest. If that's something other than a right triangle, it'll be a little bit harder to do. But we can handle it. So let's do one where we've got a right triangle in there to start with. I think that's my first example. The area of the sector minus the area of the triangle. All right, let's find the area of the segment, or ST, to the nearest hundredth. Now, area of the segment, it's talking about the segment of the circle. So let's find the area of that sector to start with. Okay, details, we've got a 90-degree angle. We've got a 4 meters for that length. area of the sector, that's what we were just doing. Sector. Area is m over 360 times pi r squared. What's the degrees for that sector?
About
90 degrees. 90 degrees. And the radius is 4. So 90 over 360 times pi 4 squared, that's going to find the area of the whole sector. I'm going to kind of leave it there and keep thinking. The area of the triangle. So we said we're going to subtract the area of the triangle. Triangles, typically 1/2 base times height. It's a right triangle. What would be the base and the height of the right triangle? B? Yeah, both of them are 4, right? Because the radius is the same length whether it goes out or whether it goes up. So 1/2, 4 times 4 is the area of the triangle. Then we're going to subtract those and have the area for our answer. Okay, I'm ready to do some calculating. So it says this comes out to be just 4 pi because it's 1/4 of 16 pi. That's 4 pi. And we're going to subtract 1/2 of 16, which is 8. And if we're doing it just in terms of pi, you can't combine those because they don't both have pi's. It's not like terms. So it did say nearest hundredth, so that's why it's showing that we come up with 4.57 square meters. And you can check my calculation, make sure I rounded right. So there is the triangle, or sector minus the triangle. All right, let's try one that doesn't have a 90-degree angle. Okay, so second example. This time we've got 120. I'm going to draw it turned differently. I'm going to draw it this way. So we're going to try and find the area of this. All right, so what do we find first? Anthony, what do I need to find first? What do your notes say to find the area of a segment of a circle? Area of the sector. So let's find the area of the sector. Measure over 360 times pi r squared. What's the degree measure for the sector? 120. What's the radius of the circle? 9. So that'll find the area of the sector. What's 1/3 of 81 pi? No. Is it 27?
27.
27 pi. So that would be the whole sector. Now we're going to try and find the area of the triangle and subtract it. Base and height of that triangle. The reason that I drew it the way that I did, does it remind you at all of like a Potham perimeter kind of idea? What did we do there? We dealt with the central angle. Well, if this arc is 120 degrees, how big is the central angle?
120.
120. This perpendicular, which isn't really the apothum, but that's going to be the height for my triangle. That divides it, just like the apothum did, 60 degrees, 60 degrees. 30, 60, 90. Whichever triangle you want to look at. What measurement do I know? I know this is 9, the radius. So I know the hypotenuse. So this is why you review the 30, 60, 90 at the beginning of class. The hypotenuse is 9. What's the short leg? 4.5. And what's the long leg?
9 squared.
not 9, and not square root of 2. It's x, 2x, and x times square root of 3. So this piece right here should be 4.5 times the square root of 3. And there's another one over here, 4.5 times the square root of 3, because I have two triangles. So what's the complete base of my triangle? 4.5 square roots of 3 plus 4.5 square roots of 3. How many total square roots of 3s would that be? 9 square roots of 3. So the base is 9 square roots of 3. The height is 4.5. As you think about my triangle, make sense what I did? At the central angle, I divided it in half. I knew the hypotenuse. The short leg is half of that. Long leg is that times the square root of 3. Why do I have 9 square roots of 3? Because I want this whole triangle, so I doubled it. So let's go to a decimal now. What is 27 pi minus, I'll write it up one here. 27 pi minus whatever 1/2 times 9 square roots of 3 times 4.5 is. Nearest hundredth shows me 49.75. So it's coming out right. We need another sample. And we don't want to have to. All right, let's do the last little part then. Got 3 examples on the board of those segments of a circle. Okay, when we try and find how long the arc is, it's just like the fraction of the area, but it's a fraction of the circumference. Arc length is the distance along an arc measured in linear units. So how long is the crust of that pizza or that pie, or something like that? Just how long is that? How many inches? How many centimeters? So the whole circumference of a circle, if you remember, one form was 2 pi r. That's one formula for circumference. Multiply that by the fraction of the circle that we want, and that gives us the length of just that arc. So if we did the fractions a little bit, or pretty good earlier, this will be another one that we can do easily. Let's do a few samples. Find the length of arc FG. Now, is FG the minor arc or the major arc? Minor because it has 2 letters there. Okay, so the length of the arc, give answers in terms of pi and rounded. So we're going to do the circumference, 2 pi r, radius is 8, times 134 over 360. I don't think that fraction reduces very nicely. In terms of pi, and then multiply to get a final decimal. Michael, what are you coming up with?
That's okay. 18.7.
You have to still multiply by pi, or are you done?
I'm done.
18.71 to the nearest hundredth. Any problem getting that calculated? Did you get it? 2 times pi times 8 times 134 over 360. That's the final decimal. If you want to go in terms of pi, just divide that by the pi symbol. That will get you that. All right, how about find the length of the arc? It has a measure of 62 degrees, and the circle has a radius of 2. calculator coming up with weird
I
form.
got fractions.
Okay, I was thinking we found a key. We pressed, was it this one? Second with that?
So I need
Okay, and let's see, do something that's gonna get a fraction maybe, and then we'll press that. Here's what the answer is if you're ready and waiting. Okay, so that still
Yeah.
needs to be multiplied then by pi
Yeah.
to get the other.
Right.
All right, question on that one? So 2 times 2 times 62 over 360 is where the 0.69 came from. All right, let's try another one. Arc GH. Answers? 4.19 to the nearest hundredth? All right. Any question coming up with those? Those calculate pretty easily. Now, those formulas are right above me here. The length of the arc, fraction times circumference, pi r, and below it, the fraction times area, gives you the area of the sector. So those formulas are real close with the fraction. Make sure you're doing the right one at the right time. All right, let's use the last 15 to 20 minutes and work on some assignments here. The one that is for today's lesson, page 767,